Hey everyone, and welcome back to the Virtual Eclipse Community Meetup. I'm Stephanie Swart, your host, and today I'm joined by Emily Zhang and Heiko Rupp, who are going to be presenting on Istio programming model for MicroProfile. Take it away, guys.
Thank you, Stephanie, for having us. I'm Emily Jiang. I'm the Liberty Architect for CDI and MicroProfile. I work for IBM based in the UK. If you have any questions afterwards and etc., you can always give me a tweet message on my Twitter handle, so Emily FH Jiang. By the way, today's session is about MicroProfile positioned as Istio's programming model. So Heiko and I will go through why is MicroProfile is seen as Istio's programming model. Okay, Heiko, over to you.
Yes, so my name is Heiko Rupp. I work for Red Hat here in Germany. I'm Chief Architect, Platform Architect for middleware monitoring, so I'm working a lot in the MicroProfile metrics area, but also with another foot on the Istio side or the visualization of Istio. And so it's natural to also be involved in the service mesh working group within MicroProfile. And you can reach me, as Emily said, and also just make sure to join our MicroProfile working group sessions. We will have some links at the end to be part of the game and of the fun. So, Emily, up to you.
Okay, thank you. Okay, in today's session, we will have two parts. The first part, I will go through the slides, and the second part, Heiko will do some demo together with some coding examples. So that after this session, hopefully you will understand a lot about Istio and also MicroProfile. How can you make them work as a really nice ecosystem together? Okay, so first of all, let's talk about MicroProfile. For the ones who do not know MicroProfile is kind of is a really open community and a welcome community. It's a vendor-neutral programming model designed for Java microservices. So this is kind of fill in the gap in the Java EE lack support for microservices. And it's provide the capability to build configurable, fault-tolerant, and scalable and monitorable microservices. Also we do a very frequent release. So at the moment we do like 3 releases per year. So the next release will be in February time. So as you can see at the bottom of this page, there's many companies joined this community: IBM, Red Hat, Tommy Troy, Piara, London Java community, and so on. Oracle also joined as well. So this is today's session. We have 2 parts. One is the MicroProfile, one is the service mesh. I give a quick overview about service mesh. Service mesh basically is kind of the group of services. Is kind of maintain or makes the service-to-service communications and fast, resilient, and secure. So this is basically when we start doing microservices, and there's a little microservices hanging around, and you need a coordinator to manage them. Here comes the infrastructure for doing so, which is called service mesh. Okay, why do we need a service mesh? Heiko has used a service mesh as I explained before. Heiko, would you like to add something about the reason or using service mesh?
Yes, thank you, Emily. I mean, if you come from the past with a monolith, everything was together in one piece. And when you had a method call, it sort of could never fail because either your entire program failed or nothing failed. I mean, there are some edge cases, but virtually it could never fail. And if you had a problem with slowness, you would attach a profiler to that single binary and record calls on that one and see where it's the slowness. And also they were basically, except for attaching a debugger on the program, there was no way to wiretap communication in method calls and so on. And now in a service mesh or in a service-oriented architecture microservice environment, you go ahead, decompose that monolith into many smaller pieces that communicate over a communication network with each other. This could be on the same host, but also distributed onto many machines, and these many machines could even be distributed around the globe, which means they are the data goes over the public network, so you want to have encryption on your calls. The remote service could not be there because someone cut the cable, so you need to have a way of reacting to that in your calling service. You want to make sure that you can reach different versions of your backend service for things like trying out a new version and seeing if you move the button to a button to the left, if that helps you getting better click rate in a lot of these things. And you can do that a lot manual, or there are also some helper libraries, but you can also use a service mesh as a platform service so that you can concentrate on your business logic, and the platform provides a lot of these services that I've just mentioned to you for free, between quotes.
Okay, thank you, Heiko. So now you have an idea, like if you do microservices and when the number of microservices goes up, you need to consider about service mesh. So service mesh is like to manage service to service communications. It will be able to do the observability and able to make the service to service communication secure, and also be able to route the communication to a different service or a different version, etc. So this is kind of once when you call into another service, and the service mesh will be there to help you to be able to like a route to a different service or more reliable service and make the communication secure and etc. So in the service mesh infrastructure, there's a few examples or product. One of them is called Istio. There's some other products, Linkerd and etc. Istio is most popular at the moment. Is the service mesh product. It's Istio was released. The 1.0 version was released at end of July this year, and after release, it was becoming very popular. And at the moment, there's Istio 1.0.3, so it's a very frequent release as well. So Istio is a service mesh, is designed to make the connection and management and microservice core communication more secure. Let's have a quick overview about Istio. Basically, if you try to understand Istio, you just think about Istio has two parts. One is the data plane on the top. Basically, you have the sidecar proxy together with your microservices. So when one microservice, like in this example, service A call into service B, you do like once you directly mention service B endpoint, you do not directly go through service B. Instead, you go through the proxy. Sidecar proxy is more like a minion for per se. So the proxy and then can add all the quality service and then be able to do a mutual TLS and etc. to call into service B, or is be able to do some fault injection or do a canary deployment and etc. So this is how it works. And the other part is the control plane at the bottom. Control plane is more like, okay, so the proxy is more like a minion, and the control plane that tells the minion what to do. So this is kind of all the policies and telemetry and etc. And also security, a certificate and etc. can be managed by control plane. So this is kind of very quick, bird's eye view into the service mesh. As I mentioned briefly in the previous slides about MicroProfile, MicroProfile has been around for just roughly about just over 2 years old. It has 7 releases in these 2 years time up to now, and also we released the 8 brand new specification. It has the config for tolerance, health check, metrics, security, open tracing, open API, REST client. This is all, to do with how to develop microservices. Obviously, like service mesh is to manage microservices, and MicroProfile is to develop microservices. So that's why it's kind of, hence this is kind of, this session is we want to look into how these two can work together. Is MicroProfile works well in the Istio? Is microservice written using MicroProfile work well in the Istio infrastructure? So in the next few slides, we will take a detailed look at that. So in the next 2 slides, I create a table. Basically, want to list all the capabilities or most capabilities of Istio and also MicroProfile. So for Istio, obviously, it can do routing or load balancing. MicroProfile is, remember, MicroProfile is a programming model for developing microservices. So it doesn't interfere with infrastructure. And Istio, it can configure microservice. For example, if you deploy Istio on top of Kubernetes, and Kubernetes has a config map, you can configure the configure properties. And MicroProfile came up with some really nice and easy APIs. It can directly inject the configs specified in the config map into the microservice. And the health check. So obviously, in the service mesh, you want to know when one microservice is not well, and then the infrastructure can go ahead to destroy it and then create a new instance. So Istio can use Kubernetes, like if it's on the Kubernetes, and use the liveness and readiness probe can find out whether the particular Istio services is healthy or not. MicroProfile directly provides some the health endpoint and also provide health procedures. So you can write your own business logic, can tell the infrastructure whether the microservice is healthy or not. And also for the metrics, and Istio can add some metrics, and MicroProfile also can add kind of very detailed metrics. So this they can all be viewed in the metrics like a viewer and etc. Prometheus. Automatically you can install in together with Istio. And the following one, the distributed tracing. So it's Istio can directly use Jaeger and to view the tracing span. And however, Istio asks the application to automatically to propagate the 7 headers so that Istio can do the trace correlation. It's really nicely MicroProfile did the job, straight away. MicroProfile automatically propagate these 7 headers required by Istio for the JAX-RS. However, it's not every case like all these trace headers were propagated, and for the rest of the client they were not. However, in the next release version of the MicroProfile REST client, we are adding that support. So basically, I want to give you kind of the impression is when we work on the MicroProfile specifications, we have a bigger picture, which is the service mesh. We want to define the best programming model for these microservices perform well in the service mesh. So for APIs, obviously there's application kind of related information. So MicroProfile takes the full control. And for security, Istio can do the mutual TLS, basically the can add transport level security. And as I mentioned earlier, MicroProfile is a kind of programming model, doesn't operate on that layer. However, MicroProfile and Istio can do role-based access control. So if you have a Istio role-based access control switch on together with MicroProfile, you will get the intercept. So basically, when they do a kind of so MicroProfile JWT like a security will check this authentication authorization, and then Istio also check the authentication authorization. Once your microservice fulfill the request, fulfill all the authentication check, and then you can the request can go through. And the routing and load balancing, that's done by Istio, and fault injection, Istio can do that. And for fault handling, so this is the area both MicroProfile and Istio can do, and sometimes they have potential conflict. So they both can do timeout and retry and circuit breaker and bookhead, like a semaphore version of the book flavor or bookhead. However, MicroProfile can do the thread pooling type of bookhead. Basically, is like automatically spawn off a new thread. And the big mention I would like to remark on is fallback. So MicroProfile provide a fallback capability which Istio cannot. And the ideal ecosystem is you could use Istio's fault handling and together with MicroProfile fallback capability. And MicroProfile can do all kinds of communication fault tolerance. However, Istio can only intercept HTTP calls. So if you have to use HTTPS in your microservice application, and you have to use MicroProfile, and you will not be able to use Istio. However, if you can write new microservice call and use HTTP, and you can use the Istio TLS can directly convert to HTTPS. So we have a worker group and to investigate and to build a good ecosystem. We have a repository called MicroProfile Service Mesh. I strongly recommend people to browse this service mesh and join the worker group, as mentioned by Heiko earlier. So both Heiko and I are actively involved in this worker group. We are trying to produce some specifications and how to best come up with the ecosystem. And also we have a sample microservices example, which Heiko will demo in the second half of this this session. So that has a service mesh, service A and B. So it's in the next few slides, I will look at the MicroProfile together with Istio. Basically, the service A and service B all being developed using MicroProfile programming model to see how it can fit in perfectly in Istio service mesh architecture. So first, for the config, I will go through these slides fairly quickly so that Heiko can show you the demo and also talk you through the code. So for the config, on the left is the MicroProfile config. So you can see at inject configure property. This is all MicroProfile APIs can directly inject the property called IO Liberty guides port number and you can specify this port number in the Kubernetes config map. This is a talk is based on the Istio on top of Kubernetes. So for health check and the MicroProfile health on the left, you can specify the health procedure. You can implement the health check with the annotation and health, and you can put your business your health procedure algorithm there. And then in Istio, you can directly configure the liveness and readiness probe, can directly poke the URL, for example. For the metrics, the MicroProfile can add a few application specific metrics like counted and how often this method was called, for example. And then all these metrics can be viewed by the Prometheus, automatically supported by Istio. And obviously, Istio can add any more metrics, but you can see all the metrics. And also you can query them and you can view them in Grafana, for example. So for the MicroProfile open API on the left and this tags, you can specify the API response. You can give the description and also the operation. All these APIs. This is annotations MicroProfile open API. And then it will automatically expose endpoint / open API, so you can browse it to find out what kind of services a particular microservice supports. For the MicroProfile security, which is called JWT, basically it's based on the JWT, which is really good because Istio also assert is their authentication authorization also supports JWT. And in this MicroProfile enabled applications, you can generate a JWT compliant token. So that token automatically being able to understood by Istio infrastructure as well. For the MicroProfile open tracing, so as I mentioned earlier, and this spec is pretty smart. Basically, all JAX-RS requests will be automatically traced. You don't need to do anything once you have MicroProfile enabled features like open tracing is enabled for your application, and all these the HTTP, the 7 HTTP headers required by Istio automatically propagated. For the fault tolerance, as I mentioned earlier, there's a bit overlap between the Istio and the MicroProfile. MicroProfile actually can do very fine-grained the fault tolerance, and Istio can do the kind of coarsely grained fault tolerance. Basically, this is MicroProfile this makes communication even internally also resilient, because for the Istio, your communication has to go out of your service and then go to another service. Only this service to service communication, will be of resilient. So it's this is what I said earlier. The other thing is the MicroProfile, because this fault tolerance is inside the application, is irrelevant to what kind of communication channel you go through. It can do it applies this fault tolerance capability to HTTP or HTTPS. For Istio, because obviously what it can do is it can only hijack HTTP request and then open up with the request and add some various headers, for example, it cannot hijack any HTTPS requests. So there's a kind of overlap and between the HTTP calls and if it's a microprofile in play and also Istio in play, and also this communication is directly you call service A, directly call service B, use HTTP directly, and in your service A application you add the retry, for example. If you also configure the Istio to do the retry, you will end up to do a multiple number of retries. However, when we design this microprofile for tolerance, we consider this service mesh Istio capability. We introduced the property called MP for tolerance non-fallback enabled. If you if you have this microprofile for tolerance in your application, you can automatically switch them off, except fallback when you try to use Istio. So you only need to put this property in your config map. So it is like a retry timeout, circuit breaker, bookheads will automatically switch off except fallback. So this achieve kind of like ecosystem. So this is ecosystem use microprofile fallback together with Istio server for tolerance. So to move forward, we even look at the kind of more kind of intuitive scenario. Whether it's I know it's some people complain it's difficult to do the Istio rules, and we even we are trying to prototype to see if you're writing your microservice using microprofile for tolerance, maybe we can directly create Istio config rules, like we can directly map them, and then during the creation, we can directly, if it's HTTP, we can directly switch off a microprofile for tolerance except fallback. So this is kind of the application developer can aid the DevOps can automatically create the config rules for Istio. So with that, I think I'm dead like half an hour. I'm good on the timing, so I give you some time to do the demo. So let me stop sharing.
Okay, Emily, then I'll share my screen.
Yeah, let me stop sharing. I'm on time now.
And now you see the Kiali console. Kiali is a UI and front end for Istio that I'm also working on with my group at Red Hat here. And what you see on screen is a snapshot of the application that we have developed in the Service Mesh Working Group to basically showcase and investigate the behavior and find out things like turning out off retry and so on. So we have a service A. This is in this case a Thorntail server, and we have our service B, where we have two servers. One is implemented by Open Liberty and the other one by Thorntail. This is a snapshot. I've paused that. And all traffic that's coming into the mesh is going over the Istio ingress gateway. The ingress gateway is also an envoy proxy that is basically an edge proxy into the system. It's logically sits on top of the Kubernetes ingress. And when you have, for example, use tracing, it starts adding trace headers and can also report telemetry like all the other sidecar proxies, so that you get a full picture of metrics, response times, and so on. And here on the connecting edges, the 0.26, that's a request rate per second. I will unpause that, and once I do that, it will go all gray because I don't have any traffic. So let me then switch over This is the URL, Istio Ingress Gateway, Istio System. Let me make it a little bit larger. And then /mp service mesh sample A, sample/service A. And this is the service A, which is giving a message, basically on which deployment it is, and the user agent that's coming in, so my browser. And then it's calling out to service B over that client here. No, it's already in the service B. Again, we see on which host it is, also here, and also the passed in user agent. I will come to that later, why this is interesting. And now when I click on refresh, you see it's service B Liberty, service B Thorntail. So basically the traffic is load balanced between the two evenly. And we have a display for security. There are no lock symbols at the moment, meaning the whole traffic here is unencrypted. And I want to change that now. And if you have ever set up SSL for Java or even other runtimes, like having your Java application talking to some Python backend or the other way around over SSL, you know that this isn't trivial. So I've created here a little PHP application, basically to only show you some YAML and then apply it in the system. And this is the YAML that you need to make the communication use mutual TLS. There are two parts to that. First, there is the policy, which says, how do I, as a receiver, do I require TLS or not? And here, for the service B service, I say, okay, all my peers need to do MTLS. There are some variants that you can choose, but here it's just MTLS. And the other part is a destination rule. This tells all my senders that want to talk with service B that they need to use Istio mutual TLS as a traffic policy. So I don't say service A, if you want to talk to B, use TLS, but I say if anyone wants to talk to service B, use TLS. So I install that. Installation means I basically run command. It's called OC here, but it's the same as kube control. It's the OpenShift version of it, but otherwise it's virtually the same. On the namespace MicroProfile, and I have this config file that we've just seen, and we were successful. So let me go back to Kiali. Of course, we don't see anything because there's no traffic. So let me start a traffic generator on a different screen, and then we should quickly see some traffic coming in, things going green, and we should see some log icons. Here we go. That tell me the traffic between service A and service B is now encrypted. Again, if you go to this one, if you remember how hard it is to set up TLS on Java and even on other systems, there may be even systems where you don't have that. And here you can really polyglot create your service A or service B in whatever language framework you want. And with these few lines of YAML, you get TLS, mutual TLS. It's actually even possible to specify, instead of a policy, a mesh policy, and say every communication in my whole mesh should be TLS. And likewise, have a default destination rule that says star.cluster_local. So sending to whatever is in my cluster should be TLS. So with 10 lines of YAML, you get all your communication secured. That's pretty cool, I think. So let me uninstall this one and then show you something else. Very often, I mean, here we have two versions of our service. So logs are still in here because we get them from telemetry, and we're fetching the last minute. So this is why it's still present. This is also something you need to remember going forward when I make some other changes. But now I want to have, for example, Liberty or Thorntail get more traffic than the other one. I want to make a canary deployment where I bring a new version online and only want to check it with a little traffic before it gets hit by everyone, just to try it out. And we can do that. Service B canary. we have a virtual service here. That's basically a definition on top of what a Kubernetes service is. And this applies to host service B service. And I say for HTTP, the route, we have two destinations. One is the service B with a subset called Liberty. I come to that in a moment. This gets 95% of the traffic. And I have another subset named Thorntail that gets 5% of the traffic. And then down here in the destination rule, I have a specification again with the host. And here I have the subset definitions. And I can define them in many ways. One way of doing that is just taking labels. So this is label version Liberty, MP13, and Thorntail 13. And now let's install that. Destination rule created, so that looks good. And while the traffic is shifting here, let me go over to the workloads. We have the service B Liberty, service B Thorntail. And when I go into it, you see here, these are the labels: app, service B, MP version, runtime version. That's something we have defined in the service mesh working group to be used. Istio itself recommends to have the app and the version label to be always present for your applications, so that you can basically get some grouping by label, like you see here. Service B is grouped together. And in theory, we should already see the traffic shift. Not sure why it's not doing that. So while we wait, let me show you something else. As I've mentioned service already. When you look more detailed at how a Kubernetes service is set up, you see that you have always a workload, which are the pods, and you always have a service definition in front of it. And these service definitions, this is also where these virtual services are applied. This is why you see here the fork item and the virtual service applied. And you see also here has virtual service. Traffic shifting is not happening as I wanted it. I'm not sure why. Let me just disable that again and show you something else. That's the presentation effect, obviously. Let me switch off the traffic generator first. And now browser routing service. When in the past, I have been working on projects where we had to support IE6, where IE6 could not do some things that more modern browsers could do, SVG graphics, or was it PNG or something like that. So it's possible to basically say, if a traffic is coming in for IE6, use the left service, or put it all on Liberty. And if it's another browser, put it all on Thorntail. Or here in our example, we use Firefox. Again, a virtual service with a routing rule. And we do an HTTP routing rule. We will match for headers. And if we find the header user agent, and this user agent matches this regular expression, then we route to the Liberty service. Otherwise, if we do not match, we go to the Thorntail subset. Here again, I have these subsets set up in a slightly different way. So let's try that. And so it was created. Now when I go here, I should only get Liberty. You see, Firefox is always, nope, not always, apparently. Again, presentation effect. Not sure what's going on, but at least that's the theory. Again, presentation effect. Okay, and for this to actually work, you need to do something. And I've written an article some time ago about, at that time, tracing, and Emily already mentioned that kind of. This is a situation in this picture where you have a request coming in over the browser. It's going into the Istio ingress gateway, which is an envoy. The envoy is forwarding the traffic to the sidecar of our service A, which ends up at the JAX-RS endpoint. And then we have the MicroProfile REST client, which is starting a request towards service B. This request is going again in the sidecar, going to the other sidecar, and ends up in service B. And the user agent header that's coming in from the browser is now not forwarded within service A. And this is also the situation, or has been the situation, with the tracing headers. And so what you need to do is take these headers, the tracing headers, end user, and all these X-B3 headers, take them from the incoming request, store them somewhere, and then forward them. And when I go to my service B implementation, you see here I have the MicroProfile REST client, and then I do a call where I specify these headers as well as the user agent. And this way it's forwarded from service A onto the service of service B. And here the virtual service of Istio can take it and go forward. And the other thing that I wanted to show, also Emily mentioned that already, here this is our call method, and if the call to service B fails, we have defined we need a fallback. And this is down here, the fallback method. That's something that you still need to provide. That is something Istio can currently not do for you. One could in theory say, okay, specify a different pod that is doing the fallback for you, but it does not exist. So MicroProfile fault tolerance to the rescue for this fallback. The other thing when I do these kind of calls, and I've mentioned that already, is the tracing. Now I have here the Jaeger UI. And when I go into the Jaeger UI, find traces. A few seconds ago. So we had this trace, and here we see it's, let me make the font a bit bigger. It's coming from the ingress gateway into the service A Thorntail. We see it's inbound port 8080, HTTP status code 200, response size 819 bytes, and this is the server span. And the first thing it's doing here is calling out to Istio policy, to the mixer, basically to learn where it should call to. This is not interesting for us. And then service A, now we should be in the client, span kind client. So this is now calling out to service B, port 8080. There are the two vertical bars here, meaning no specific version, because this is something Envoy is doing. It's calling out. Service B is also making some checks. So we should be in the server span of service B. Yes, server and inbound. And it's, I think, also doing some checks. Let me collapse this. Okay. Let me go back and let's just go into this trace again. We can see here at the top where the time is spent, and see that it's most of the time is here in service A client, which is then calling service B, and this is taking 1 second. And the reason for that is that within service B, we have some sleep logic that's doing random sleeps, so that we can try out something like retry and retry logic within either fault tolerance for MicroProfile or also on the Istio side. So distributed tracing is a very helpful thing. And a very cool thing is, of course, you do have to, this one even took 2 seconds. This is a quicker one. The very cool thing is you do have to propagate the headers, but this is something that MicroProfile will do for you completely in the future. So it's transparent to you, but you do not have to modify your code and can already directly find just from the Istio telemetry where you have slowness, where you need to improve your services. Good, that's that. And now let me disable this rule and hope that at least the presentation gods are willing for my last one. So we have had these services, service A and B, here inside our mesh, inside our Kubernetes cluster, but sometimes it's also needed to call out to other services outside of the mesh, something like Google or your whatever database server. And there's the possibility to define so-called service entries in Istio. You specify a host name that's also used down there. Either when you do static resolution, you provide the endpoint address yourself. Otherwise, there's a DNS name taken. And then in a virtual service here, you can say for the route, for the destination, 70% of the traffic should go to my internal services and 30% should go to the external service, mesh external one. And again, a destination rule here saying what internal means. And here I'm just using a different label combination. And let me start my traffic generator. And now you see here, we don't have yet the green, but here we see the mesh has identified the external service already. And now we see traffic coming in. And the traffic is now going here and it should also pretty quickly end up on my external host. Okay, again, demo gods today. So I think I'll just get back, give my screen sharing back for some last slides. So am I back? I'm not sure. So can you see me? Or not see my screen? That's the rather question.
Yeah, I can see you. I can
Perfect.
see you. I have the last screen share. This is so this is takeaway for the references. The top one is I wrote article about MicroProfile and Istio, and for the Eclipse newsletter in September edition. So that's went to a lot of details and look at each technology in great depth. And hopefully this article will give you some kind of more explanation about what we have covered in this session. And second one is the Heiko's, Heiko briefly showed this article as well. So it's about the Kali and the service mesh, all this configuration and etc. and your experiment. And the following three link is MicroProfile service mesh, document this ecosystem between MicroProfile and Istio. And the second, the service A and service B is this is the application Heiko demonstrated. So you can get a source code, etc. there. I would love to have you participated in the worker group. We have meet up weekly. So tomorrow 1 o'clock UK time we'll meet up. So hope like if you go to the MicroProfile service mesh, and then you can click on GitHub, and then you can join the conversation, and then you can ask a lot of more questions. And the following few link is if you want to learn more about MicroProfile, go to microprofile.io. If you like this service A and service B is can be deployed in either OpenLiberty or Soundtail. If you want to find more about OpenLiberty, go to openliberty.io. If you want to find more about Soundtail, go to soundtail.io. So they are really fast start application servers which implement MicroProfile programming model. That's it for this session. Are there any questions?
Thank you, Heiko and Emily, for a fantastic demo and presentation. At the time right now, we don't have any questions, but feel free to drop them in our YouTube chat, on Twitter, or on our meetup page, and we can get them right over to Heiko and Emily. So again, I'd like to say thank you to Heiko and Emily for such a great presentation and demo. And this is the last webinar for 2018, so we will see everybody next year. So have a great day, guys.
Thank you, Stephanie, for having us.
Yeah, thank you, Stephanie, for
also thanks for watching, and have a good end of year, everyone.
Yeah, happy Christmas. Okay, great. Thank you all.
Thank you.